Wow-wee. Good morning. What an exceptional time to be alive. I'm sure you'll agree with me. Our access to information has never been so fluid. I read a stat the other day that said that anybody with a smartphone and a connection to the internet has more information than the President of America did in 1994. That just blew my mind, our ability to reach billions of people at the ease of a click. Today, we can impact 3.7 billion people for free. How big, how bold, and how courageous are our questions about this future? In order for us to get ready, we need to make sure we're becoming architects of this reality. And with tools like Autodesk are giving us today, it's never been easier to create and imagine our reality and bring it into fruition. My name is John Sane. I'll be your MC this morning. I'm highly excited to be part of a company that's really creating the reality as we move towards it. We have an exceptional day ahead of you. You have over 30 track sessions that you're going to be downloading, some incredible innovation that's really going to help us all move forward right here in South Africa. We have over 700 delegates registered, the biggest event that Autodesk has ever had. It shows us that we are all starting to take this power of creating our reality really, really seriously. I'm going to bring on Simon Bromfield up on stage just to talk to us for a couple minutes. He's the country manager for South Africa. Simon, please join me.
Thank you very much. Last year, when we did Autodesk University here in Cape Town, I actually told the team that I want to grow this event. We did 550 people last year, and I said to the guys, you know what? Autodesk University isn't big enough. Let's make it Autodesk Africa, Autodesk University Africa. And I challenged the guys to invite our customers from the continent. So today, in the audience, we represent 17 different African countries. Together with our guest speakers, there are over 30 different countries represented here today. I think that is a phenomenal achievement, and thank you guys. Yesterday, I was very fortunate to attend the Autodesk Foundation meeting where we met with some of the leading minds that are looking at how to use technology to change some of the problems that are facing Africa, and I was absolutely blown away. Sitting in a room, listening to how the United Nations Habitat for Humanity team are using Autodesk's technologies like InfraWorks to plan refugee sites around Africa. The second group of people that we met were the people from the Nubian Vault Society, where what they've done is they've resurrected Nubian building technology and actually are using it to build sustainable houses. This concept was lost in the history, and they don't use any timber or anything other than bricks to build massive structures. It was absolutely amazing to meet with them. And one of the third group of people that really resonated with me was the guys that are from Kenya that are tackling the concept of waste management, of human waste management. And what they're doing is they've created a sustainable business for people that you actually own a toilet and you rent it to the community. And what they do with the waste, the byproduct, is they then take that, put it into a fly farm, harvest the larva, sell that to chicken farmers to grow chicken, and the byproduct goes into fertilizer to create fertilizer. An incredible solution that is just being built here in Africa, and there's this amazing community of users that we have. So what I want to challenge you today to do is we have a lot of partners outside in this area and a lot of people here. Please go downstairs, go upstairs, meet with them, and look at how you can use Autodesk technologies to change your reality and your world. Thank you very much.
Thank you, Simon. When technology starts affecting the whole globe, we see a trend called the democratization of knowledge. This giving us the ability for everybody to access this to improve humanity's life. I really get excited when I hear about toilets starting to get innovated. Now we know we're really starting to create some exciting innovation. That's not a shit innovation. So, let's get some house rules out the way. First of all, please keep your mobile phones on silent. We really want you using them, but if you could keep them on silent to make sure that the focus is on the speakers that have traveled from far and wide to share their knowledge with you. If you're still smoking, I think you need to do a bit of research, but after you've done the research, please smoke outside, way, way far away. There are 2 emergency exits just outside of the auditorium, just behind you. Bathrooms on either side of the auditorium. I'm sure you've already seen them. There's an information desk. As you walk in, there's a lot of AU helpers running around. Please ask them if you need anything. If you haven't already booked your track sessions, please do so. Speak to any of the AU representatives or the desk outside. And please vote for your best and favorite design at Design Now competition. There will be some prizes being given out throughout the day. A couple more. Validated parking tickets. Please get that at the desk before you leave this afternoon. The Wi-Fi code, if you're interested in it, is AU South Africa. AU South Africa. Please link into that. I want to say a special thank you to our main sponsor, HP, and all the other sponsors. And also, what we want to make sure is that you're using the hashtag AU South Africa for Twitter or at AU South Africa for Facebook when you are doing any posts. There are some spot prizes throughout the day for the best tweets and the best Facebook updates. So please get busy sharing that on social media so we can get a whole bunch more people excited about what's going on. We're also live streaming this on YouTube for anybody that's lazy and still in bed. They're pretty smart on a day like this in Cape Town. Hello, YouTube. Everybody say hello to YouTube, please. There's thousands of people out there watching us. So next up, I'm going to be calling up somebody that's come all the way from the States to share some knowledge with us. We're going to learn about some really exciting and inspirational trends and customer stories, some that touch on disruption and innovation, and others on sustainability. I'm very happy to bring up somebody that's so entrenched in the Autodesk culture and somebody that's going to be sharing really what's going on from the mothership. Could we have Callan Carpenter, the VP of Global Name Accounts, join me up on stage? Thank you. Welcome.
Thank you, John. John, you forgot that the secret to successful presentations is much like the secret to successful marriage.
Wow.
Low expectations.
Okay.
So we want to keep the expectations low. Thank you for that introduction. Thank you, everybody, for being here at AU South Africa. I am really personally thrilled to be here. I have a global role at Autodesk. I manage our global named account program. That's our strategic customer program. And as such, I get to travel literally around the world and see many interesting places. But this is my first visit to South Africa and to Cape Town. And I'm already falling in love with the place. This is one of the best kept secrets in the world. It really, really is. This week I had the pleasure to hike on Table Mountain, to explore down the peninsula to the Cape, to see some amazing landscape. But of course, today we're going to talk about a different landscape. We're going to talk about the landscape of ideas, of technology. And this landscape we call the future of making things. You heard Andrew refer to it in his welcome video. And this is a topic that's really near and dear to our heart. It's something that if you've been involved in the Autodesk conversation for the past few years, we've been talking a lot about this. And we have a very particular point of view about where the future is going in terms of how we make anything. And in fact, we see a number of significant disruptions in the nature of demographics, consumer demand, and of course, technology. And these disruptions represent simultaneously tremendous opportunity to add new value, to generate new revenue streams, and also threats. Because if we ignore these trends, if we ignore these disruptions, you can believe your competitors will not. All right? So I'm going to touch on just a few today. I'm not going to go very deep because we've had this conversation for a few years, but I want to make sure we're level set. And then later, a couple of my colleagues will go much deeper in a couple of these areas that we think are particularly pertinent right now. But let me start with, when we think about the technology disruptions and opportunities out there, we tend to categorize them in 3 buckets. First of all, disruptions in the means of production. And when I say production, I mean both physical production, the making of things, automobiles and copiers and buildings, and also the production of ideas, intellectual production. The next big trend we're going to look at is connectivity or connection. The world is moving to a connected state, and that has tremendous implications on what we build and what our expectations are for how we interact with the things that we build. And then finally, I'm going to touch on a disruption that is kind of an Uber disruption that's accelerating all the rest, and that's machine learning. And that's something we're going to talk a lot about today because it is so compelling and so important that we understand how this is going to impact our lives and our businesses going forward. So let's start with production. So again, when we talk about production, we could be talking about physical production, such as this robot bricklayer that you see in the photograph here. That's a real thing, by the way. Or we could be talking about intellectual production. When I talk about intellectual production, it's how we design, it's how we create ideas and explore the solution space. If you think about technologies like generative design, we can now design things in a way that no human ever would have done on their own before. We can design artifacts, for example, for the aerospace, the automotive industry, that are lightweight, twice as strong, much more sustainable in their manufacturing processes. But the catch is, how do you build such a thing? Because most of these objects can't be built using traditional manufacturing techniques. So when we talk about production, we have to look at that connection between how we generate the ideas and then how we implement them. And here's a good example. Boeing, aircraft manufacturer. I flew on one coming over here. They will very shortly begin producing 3D printed titanium components for the 787 Dreamliner. And if you think about how regulated the aerospace industry is, how many certifications you have to go through for every part that goes on an airplane, you realize that if they're now putting generatively designed 3D printed components into that plane, it must be real. The future of making things, it's already here today. What about that intellectual production? Well, there's many, many things we could talk about here, but one that's really important, and I think critical for South Africa in particular, is the notion that no major project anywhere in the world today is done in a single location. Major projects, whether they're designing an aircraft or building a major piece of infrastructure, involve teams that are separated by thousands of kilometers of space and many time zones. How do you get those teams to work and collaborate effectively? How do you, especially when they have different points of view, they're coming from different areas of expertise, the designer, the engineer, the manufacturer. Well, increasingly we see the disruptive trend of virtual and augmented reality, enabling these teams to collaborate despite time and distance. In a way, it's like adding body language to the conversation. And of course, where we think this is going, it may sound far-fetched today, but where we think this is going is eventually, as designed, will become as built. We're going to push a button to make, and we'll think no more of it than we think today about pushing the print button and expect the document to come out on that HP printer. We will see machine algorithms that will seamlessly integrate the phases of ideation, design, engineering, and manufacturing, fill in those blanks for us. We'll send digital streams of instructions to factories that will self-configure to build whatever it is you just designed. Sound far-fetched? It's coming faster than you know. Let's talk about connection. Our expectations for the relationship with the products that are being built today is changing rapidly. We expect those products to be smart, whether it's an automobile or a highway. We expect these things to get smarter and better over time rather than growing obsolete the moment that they roll off the assembly line. We expect these products, buildings, to talk to each other, to deliver an experience that is unique to the environment in which they sit, that makes it more compelling than the sum of the parts. And of course, I'm talking about the Internet of Things here. But the Internet of Things in and of itself isn't very useful. It produces petabytes of data, but what do you do with that data? How do you turn that into information and into insight? Well, that brings us to the third major disruption, machine learning. Machine learning is really accelerating those other two disruptions, the disruptions in production and the disruption in connection. Because it's only through the power of machine learning, big data analytics, and so forth, that we'll be able to make use of all of that connected data and information. Of course, machine learning is a very broad category, and my colleague Tom is going to come up in a moment and tell you a lot more about it. But of course, it encompasses things like generative design, which I've already mentioned, robotics, AI. Really, the sky's the limit here. And again, much of this sounds like science fiction, but in fact, it's science reality. Now, there's a legitimate fear that robotics and AI is going to impact jobs. It may replace human beings in many tasks that are dangerous or repetitive today. But the fact of the matter is that in every era where we've seen a disruption of game-changing technology, whether it was the steam engine, electricity, whatever it might be, the automobile, it's always created more opportunity and more jobs than it ever displaced. So we need to embrace this reality because we're not going to stop the tide. We got to ride that tide, and we got to take advantage of everything it brings to us. So production, connection, machine learning, major technology trends, creating, as I said, both opportunity and risk. The risk is that we don't embrace the opportunity. But there's one more disruption I want to talk about, and it's not necessarily a technology one, but it's one that is absolutely in front of mind for Autodesk, and I think very relevant for Africa as well. And that is resources. We are reaching the limits of what our planet can sustain, and we have to think about sustainability in everything we do. It has to inform the way we engineer, design, and produce all the products and services that we deliver today. Why is this so acute right now? Today, there's 7.5 billion people in the world. In 30 years, there'll be 7 billion people living in cities alone. Think about that. Just to build housing for those 7 billion people, we're going to have to build 1,000 buildings a day, every day between now and 2050. How are we going to do that? I think, again, Africa, more than most continents, understands the challenge of building sustainable, effective housing for large populations. So to keep pace with this, we're going to have to support many organizations and many fresh ideas. One great example is the organization Water for People. They've got a fantastic mission. Their mission is to go to specific areas in the world and make sure they have access to clean water and sanitation. Their motto is clean water for everyone, forever. Think about that as a mission statement. For everyone, forever. And of course, we're very proud to support organizations like this by donating technology and know-how to help them achieve their mission. A little bit closer to home, we had the Midland, Maine Central Square project in Pretoria. This is a fantastic experiment in sustainable urban design. It, in fact, is an urban laboratory, if you will, of mixed use, work, play, living, in an environment that's designed to not only create zero emissions, but negative emissions. The architects for this project will tell you that there are only 19 green cities on the planet today, and this is the first one on the continent of Africa. Again, very, very proud to be part of supporting such a forward-looking activity. Let me go further north to Holland, to Amsterdam, where we see Royal BAM has built this fantastic new pavilion for the ABN AMRO Bank. Now, what's special about this pavilion is that everything about it is designed with reuse and sustainability in mind. First of all, it's built with all reused products, everything from the doors, the windows, beams, fire hoses are repurposed from previous constructions. And all of this material already has planned reuse for when the project is eventually torn down at some number of years in the future. The employees themselves even donated blue jeans that are being used as part of the insulation and decoration inside the project. Really, really innovative. In fact, BAM calls this circular design and construction because it represents a continuous ongoing cycle of reuse. And they're onto something here because it's estimated that there's a $5.5 trillion opportunity in sustainable goods and services over the next 10 years. And they're on the forefront of figuring out how to do that. So we've got a world of opportunity in front of us, a world of fictional sounding disruptions, machine intelligence and connectivity and smart products, and of course this underlying need to do it all sustainably. Is this real? Is it happening today? Well, yes, it is, of course. And I'd like to share a couple of examples of other companies that are taking advantage of these technologies to change the game within their industries. This is the Vama 12 plant in Norway. It's the country's largest hydroelectric plant. It's over 100 years old, but Norconsult was given the job of redesigning and modernizing this and making it a world-class piece of infrastructure. And they did that by bringing to bear every piece of technology they could. First of all, it's an entirely BIM-based project from beginning to end. You also see here they're taking advantage of computational design, in this case, a product that allows them to very precisely calculate the steel meshes, the rebar for reinforcing complex concrete structures like the turbine housing that you see here. But the use of technology didn't end with the design phase. They also took it to the field using scanners and drones. They were able to create digital models of the existing structure and use that to integrate the new structures in. And of course, the site superintendents had tablets with the BIM models so that they could continuously compare construction to the model and catch problems early enough before they became a major disaster. At the end of the day, Norconsult didn't just build a world-class hydroelectric plant. They set a new standard for how such plants will be designed and constructed far into the future. Let me give you another example. This is the Port of Rotterdam. At the Port of Rotterdam, they have a fantastic forward-looking organization called the Additive Manufacturing Lab, or RAM Lab. RAM Lab is looking at bringing advanced design and manufacturing techniques to the world of shipping. So what you see here is the world's first large-scale shipping components that are being 3D printed in steel, all right? It's a hybrid process that involves advanced multi-axis milling, state-of-the-art technology there, as well as 3D printing. They're going to revolutionize the retrofitting of ships. So when you think about an expensive ship sitting in port, needs a new propeller, it could be there for months. That's millions of dollars of lost productivity for the ship owner. The only other way to combat that is to maintain expensive stockpiles around the world, and that's not cost effective either. Of course, they don't intend to stop here. They believe that this same technology can be used to impact the oil and gas industry, the automotive industry, and many others where the transportation of material to a site may be cost prohibitive. Think about Africa, where it's twice as expensive to travel anywhere here as it is in any other continent. Being able to build on site, even something as industrial scale as a ship's propeller, could be a game changer. All right, so the emergence of the cloud, which is the underlying compute engine that allows us to have these technological disruptions in production, disruptions in connection, machine learning, is a fantastic platform. But where do we go from here? What's next? What's the next big platform? Well, I'll submit to you the next big platform is data. Again, we talked about it's going to be a connected world. We're going to have sensors everywhere. But what do you do with all that information? Well, Autodesk's role in this is really quite simply to use that information to feed back into the design and manufacturing process. Close the loop between design, use, and manufacture. With that data, we'll be able to drive even more impressive technologies in the artificial intelligence domain and the domain of generative design. So at this point, I want to go a little deeper into this topic because this is so important, so game-changing, that it's worth doing a double-click on. And to do that, I'm going to invite my colleague, Tom Moujik. Tom is a fellow of Autodesk. We only have 2 or 3 of those. He is an author, he's a facilitator, and he's the most interesting man in the world. So, Tom, please come on up and tell us a bit more about machine intelligence.
What? Talk about setting expectations low. Thank you so much for that wonderful and overstated material. So I work as Autodesk's fellow, so my role within the organization in the office of the CTO is to explore emerging technologies, to explain those technologies, and to help exploit those technologies, but in a good way, to exploit them so that we can democratize these technologies in fascinating and interesting ways. I will never forget that so much. So what I'd like to explore with you today and share with you today are some of the behind-the-scenes research that we've been doing over the last couple of years within our office of the CTO. Explore how machine learning and explore how generative design, how these vast ranges of technologies are changing not only the way in which we design and make things, but our relationship with technology. And it's amazing. It's really interesting. A very fascinating way in which our very way of interacting with technology is moving from one way to another way. And so I'd like to kind of walk you through this story and illustrate how you may be relating with technologies in ways that are unexpected. So let's begin with the concept of fuel. The ways we have made our ideas real has always depended on some kind of fuel. And in the industrial age, of course, it began with coal, and coal was the fuel that led forth and brought forth and propelled our ideas to make it real. It allowed us to harness steam and steel, and it introduced a brand new civilization, didn't it? It enabled us to produce this vast range of transportation networks, telecommunication networks that would transform our civilization. And as Callan has mentioned to you today, the new fuel for our ideas is, come on, data, right? And data is the new commodity. And I'd like to really illustrate how that commodity is being propelled through the pipeline of the cloud. But you already know this because you are already taking advantage of this transformation. The cloud has transformed the way in which we live. It transforms the way in which we communicate. It transforms the way in which we relax and even travel. And so today, I'd like to show how the growth of the cloud is transforming the way in which we make things and the very nature of what we make. And this change, we feel, is going to be remarkable, it's going to be stunning, and in many ways, it's going to be irreversible. Okay, so what is this going to mean for you? What it's going to mean is that your designs will no longer be locked or confined into the confines of the box that sits on or underneath your desk, and the representations of your ideas themselves will no longer be static, and the products themselves that you make will no longer be static. We are in this world of moving from fixed things to very dynamic things. So as Callan has mentioned, we're now in a world where we have the potential to build things that are deeply connected and will evolve in the world. Okay, and at the very heart of this, again, as Callan has mentioned, is our ability to capture, compute, and to create. And we have these many shifts that are occurring as we transform our technologies from passive servants to active partners. That's the heart. That's the real shift that we're seeing in the world. So let's begin with generative design. So let me ask you the question, what's going to happen when design is going to be empowered with essentially limitless computation power? So one of the changes is the way in which we relate or direct. So with traditional computation, you decide what to do. You directed the computer to do something. You decide to run a simulation. You decide to engage the computer to perform certain tasks. But with abundant computing, that whole equation actually gets flipped 180 degrees. We no longer do designs by simulations based on a design. We no longer do it just during a design, but we do it to discover a design. So with generative design, and you'll be seeing this through the course of the day in other sessions, you describe the problem, you establish the goals and the constraints, and allow the computer to explore this massive problem space and solution space to come up with an ideal solution. So it does more computation than any single person is able to do, perhaps in their lifetime. This is an amazing story. This is a chair that's designed by one of our interns. She's 25 years old. By the way, it's the very first thing that she made. It was the very first chair she made, and she never used CAD software before. What she did do is she gave the tool the goals, height, weight, and so on, and the constraints, and then chose from, I'm not sure the exact number, hundreds, if not thousands of different options, and then it was milled out. It's not only creative, but it's also beautiful, and it's functional, and it's transforming the way in which we explore. So that's one way of thinking about generative design, to generate geometry, but that's just the beginning of it. Generative design can be applied to explore the needs of individuals and the needs of people. So I come from Toronto, and we are just moving into our new office next Friday when I'm back. And so we thought it would be really interesting to use generative design to maximize the productivity and the happiness within our organization. So we use generative design to feed in the forces that influence human productivity. We surveyed our employees and asked them what their preferences were, and then we evaluated the survey data against the constraints, so where the kitchens were, where the boundaries of the buildings were, what the directions were, and then we allowed the computer to generate 10,000 options, 10,000 alternatives, and the system tried to maximize outside views, minimize distractions, and then prioritize personal relationships. So the computer generated a variety of solutions, and then we found and picked the equitable solution. So we're not just pushing Lego blocks around here. We are instead allowing the computer to explore the best possible option. So what's the shift that happens here? We're moving from directing the computer to follow the tasks that we are asking it at a low level to one in which we allow the computer to adapt and explore and to analyze and discover the best possible solution. That's one of the big changes. So what about actually creating the things that we have created a digital model for? So let's look at how abundant computing can change the way in which we physically fabricate things themselves. So robots themselves kind of haven't changed very much in the decades, nor has the built environment that people have put robots into. And we still lock them up because they're heavy, they're dangerous, they're stupid, and they move very quickly, and they don't see you if you happen to be in the way. So that's very dangerous. Also, kind of part of this relationship between robots and the structure that we build them in is that we lock down our processes for making. It's this rigid way that we repeat over and over again. And because of these rigid processes, we as human beings need to accommodate the processes of robots. So what if we flipped this around? What if we applied machine learning and abundant computation towards this? So I'd like you to meet Ash. Ash is one of my favorite robots. It's one of several in our robots lab. And so she's not very different from many of the robots that we have in the world, except we don't keep her locked in a cell. We give robot Ash this clear stereo vision and the capacity to build and weld in three-dimensional space. And so she doesn't rely on us for direction, but instead she works in a closed-loop system, continually refining and refining and refining the model that she's building based on the feedback, based on what she actually can see. So as we build more flexibility into this system, we need more flexibility to understand how to work with these adaptive systems. So we created a virtual reality environment so that we can step into her world virtually. And in doing so, interact with her in creative, more human, more intuitive ways to be able to help her build the things that we want her to build. It's really an amazing experience. If any of you have tried virtual reality in this way, it's crazy to be able to interact with a robot in quite this way. So what's interesting here is that the space no longer, that the robot occupies is no longer dangerous. So by applying machine learning, we shift from rigid ways of working to much more fluid ways of working. So many of you may have are familiar, of course, with 3D printing and additive manufacturing, and many of you might know of our work that we've done with Airbus. So Airbus, the partition panel has been generatively designed. Now, what you probably don't know about this is that it was inspired by a slime mold named Fusarium. And the slime mold, Fusarium, it works by growing to connect to food sources. And it reinforces the connections that are good ones and eliminates the ones that are not so fruitful. And so to design the partition, we used an algorithm that is based on this very natural and very deep phenomena. And so when we generated the partition, we created this very complicated thing. And the challenge that we discovered was that it's really, really, really difficult to understand. You can hold it in your hands, but it's really difficult to understand where this part might fail. But a computer could. So we can do an analysis on a single part, but on the whole structure, it just becomes remarkably complex. So another shift that is occurring, which is starting to, I think, I don't know, I find this one among the most challenging to deal with, is that we are moving from a world of inspectable, where we understand each of the objects that we build, to inscrutable. What is inscrutable? It means hard to understand. The word itself is inscrutable. And so the very nature of the things that we're building increasingly using design learning and machine learning are becoming inscrutable. So let's just recap. So the partition here allows us to see that the value of generative design. It can be used by virtually anyone. We are democratizing this technology, and we can apply and extend this technology not for just making geometry, but understanding the behavior of people, and much, much more, as we'll soon see. So data is at the heart of this, and it's driving our design decisions. And so it's a remarkable transformation. And so one of the transformations that we're seeing is that that design is sort of becoming more like a black box. And just because something is less understandable doesn't mean it's less trustworthy, because computers now, as I'm sure you know, are way better than humans to be able to recognize faces, to detect cancer, and also to drive vehicles. The accident rate is much, much lower. And the reason for this is because computation is shifting from if-then statements to insights or intuition. So they don't run formulas, but instead they are learning from direct experience, watching in the world and becoming predictive, projective, and productive, as we like to say. So machine learning works not just by following rules, but instead by following the principles or deep understanding. So another way of thinking about it is kind of like this. If-then statements are like looking into the rear view mirror, whereas computational design and machine learning is looking outwards and forwards into the world. So philosophically, that's what it means. I'll share some practical examples in a moment. But we're moving from a world of conditional to a world of insightful. So let's revisit robotics. So how can we build more efficient ways of manufacturing? So by giving our robots vision, they have an ability to see, and they can detect our presence. By giving them machine learning, we give them the ability to learn, so they're no longer locked to our processes. And then rather than having them follow just traditional conditional methods, they're learning to work in the messiness of the human world. So this is one of the, I think, really important transformations. So I'd like you to meet another favorite robot of mine. His name is Bishop, and Bishop has been introduced to the very disorderly world of Lego blocks. So using machine learning, we taught, or in the process of teaching Bishop to be really curious and let his intelligence evolve as he plays kind of like a toddler with these sticks. So like our previous robot, Ash, he's got eyes, and he also has a hand to grasp. And so he slowly is learning how to manipulate and stack these robots. Not programmed to do this explicitly, but to evolve and learn through many iterations. So he now has been able to evolve to be able to move some of this, to react to the environment, to select among complexity. But it's a slow process, as you know. So one of the interesting applications of machine learning is to separate the learning environment from the physical environment. So we created an artificial world within which Bishop can learn in. So it kind of looks like this. So we replace what he sees with his optical model with a computer-rendered model of a world. So using physics engines, be able to create a world as if with Lego blocks. And so think of this as kind of a video game in which Bishop can explore and try many things. So what's interesting about this is that we move from human time to computer time because computers can work in parallel. So we can, in the course of an evening, work on 4 or say 16 or 32 or 1 million different simulations in parallel. So think of a toddler experimenting. So at the beginning of the evening, it has no idea how to work, play with this, and then at the end of the evening has more expertise than all toddlers ever, since the beginning of time. And that's kind of what machine learning is actually allowing us to do. So as a result of this, Bishop has been able to learn very quickly, and we give them random samples, and he has enough experience to bring this into the physical world. The interesting thing about this is once Bishop knows, so does Ash and every other robot that has been networked in this. So unlike having every robot having to relearn this by themselves, it's distributed. See how it multiplies and communicates? It's a remarkable impact. And so where it gets, I think, really interesting is we can swap out Lego with, well, whatever you'd like. Chairs, stage, 3D printed logos, clothing. It doesn't matter for machine intelligence. It doesn't care. If it has enough time in a virtual world to experiment and build, it has the potential of developing insight in a way that is inscrutable and impenetrable. Wow. That's really one of the important learnings and lessons that we're understanding from this. So the shift, one way of talking about it, is that we're moving from a world of conformity to a world of variability. Okay, some examples. Maya. Anyone use Maya? Maya is a visual effects software. I was part of the Maya team many years ago, and it's insanely complicated to produce fluid effects or smoke effects. There are literally hundreds of sliders and drop-down menus and dials and so on that you need to be able to master. You can rest your career on Maya. Would it be possible to teach a computer how to use Maya? Well, in fact, that's one of the things that we've done. We've had Maya explore using machine learning what all of the different settings, the many billions of combinations, what the various type of smoke effects can be, and then show us a reference image like this one here, and the computer instantly knows how to generate the image, but as a real-time, three-dimensional interactive simulation. So apply that to the software that you're using now. Apply it to some of the complex problems that you're trying to use now. Okay, so another application is with a program of ours called Moldflow. Moldflow has a database of about 10,000 materials, and we study how those materials are actually flow and or can be used for manufacturing processes. Now, it's based on 30 years of data, and I think there's many people here who aren't 30 years old yet. So it's a crazy amount of data that we've assembled, but only 2/3 of the database, actually only 1/3 of the database database is complete. 2/3 is still, it's not done yet because it's such a slow, laborious process. But machine learning can help us scale and understand and test and evaluate the deep properties of these materials so that we can better simulate them and then apply them to machine learning, to a manufacturing process. So again, we're working in computer time to be able to process this. So the shift is moving from, I guess, programming, modeling, to understanding real-world performance. We're going from calculation to a deep perceived understanding of the world using sensors, and then cultivating intuition. You know what intuition is? It's that sense of whether something is right or correct. We all feel intuition based on years and years and years of experience. So that capacity, believe it or not, is now being transferred into the machine learning algorithms. And of all the technologies that I've seen, I've never seen one that's moved so quickly. We just recently finished a book called The Future of Making, and I got to tell you, at the very last couple of months of bringing it to a close, I was really scared because I'm thinking, this is changing so quickly. Every week there are 3 new major advancements, and so how are we possibly going to communicate that in a fixed static object? Let's look at how we can apply some of this technology to the world of construction. So we have now digitized some of the problems that happen in the world of construction. Here we have 27 million documented issues. This is a small portion of it. That's just probably 10,000 or so from 10 years of BIM data. And a program called IQ, which is part of BIM 360, takes machine learning and analyzes those problems for the purpose of predicting what could be a problem in the future based on capture, based on observing what is in the future. And the goal is to reduce subcontractor risk, to reduce dangerous situations, and to help superintendents to be far more productive than ever before. And one of our partners, Swinnerton Construction, used IQ to explore for several of their projects. And they began by where people were literally typing in the problem on site, and the computer would then begin analyzing the construction site. In fact, the whole construction site becomes computable, and as a result of that, we can apply machine learning. And we're now at the phase where we can apply photographs, scanning technology, and then the computer understands what are some of the issues that could be here. So for example, it took this image here and then processed it and found a problem. See the problem? It's damp underneath here. So that may mean that the window was fitted incorrectly. Okay, so the computer recognizes this. Or it looks at this photo here. What's wrong here? Some of the missing guardrails, so it's a dangerous, risky situation. People could die as a result of this. And what about something like subcontractor risk? When you work with a subcontractor, you want to know that organization's track record. So is it possible to capture that data? Yes. So I think the important lesson here is that this complex machine learning, it becomes accessible to push buttons. Think of 10 years ago when this thing called, what was it called? Oh, the iPhone was released. That was a decade ago. And since then, computation has grown orders of magnitude. In another 10 years, we're going to see the same rate of expansion, but more so. And so some of the aspects of machine learning that we've talked about previously will be pervasive. So it's a really good time now to really understand and pay attention to what this means. So instead of looking at project management from a rear view mirror, as we do previously, IQ looks forward and out into the world. That's the fundamental shift. And so we're expecting to, as we connect the world, as we capture more information of the world in real time, construction sites, even actuarial data, we'll be able to have a better computable model that you can use to better manage your projects and put people where they need to be, in the right place, in the right time, in the right ways, doing the right things, reducing the inefficiencies. So rather than following a recipe, we reason through observation, kind of like what human beings do. So there's an ask, and the ask, I think, is tough when it comes to machine learning. And the ask is, in order for you to drive a self-driving car, you have to let go of the wheel. And I don't know if you've ever been in a self-driving car, but the very first time, boy, it's scary, because this thing is taking off, and you really, there's this whole issue of trust. But it worked. They work. They're remarkable. We have to let go in the same way of our traditional tools to take advantage of these next generation tools as they come on board quickly and augmenting. So you can imagine a world today where computation remains finite. It doesn't change from what it is today. And in such a world, your design will stay in the box, and our software would be delivered in a box. But we don't live in that world. We live in a world where computation is growing exponentially. In this traditional old world, these are the qualities of the software, of the tools that we have. But now imagine a world of remarkable, abundant, perhaps even infinite computation. And so in this world, we don't push finished products out into the world. We have a continual exchange and dialogue with the things that we make and that we produce. So our software then, the software then evolves and to have additional characteristics. One that is much more fluid, much more intuitive, and something that's much greater than the sum of its parts. So there's a remarkable transformation that's at play here. We're getting into a world where the tools that we are using have the capacity to deeply understand our intentions, the ideas that we're trying to build, but also the way in which we build them, and also the way in which our products are going to be used, and the way in which the products actually will be used. And the combination of that, of this exponentially growing computation, is the heart of the transformation. And it's a really exciting and I think also kind of a scary time, because it forces us to rethink our relationship with the technology, letting go of the ways in which we've kind of built our careers to brand new ways. And I think what that does is it frees us up. It frees us up to take advantage of perhaps what is most human and most valuable, which is our human ingenuity and creativity. But what we do now have is the potential of working with through our technology, a true design partner, one that's not really just good at execution, but one that's also terrific at exploration. And so we're believe that the combination of these two capabilities, the left brain and the right brain, are really going to bring out the very best in ourselves, in our companies, and also in our industries. And Autodesk, we are committed to building these technologies, and we're really excited to be able to share these with you. I really say that with you, and we look forward to continuing to go on this journey together. So with that, I believe we really can build just about anything together. Thanks for your time.
Thank you, Tom. See, he is very interesting. So we've talked about how these technologies like machine learning, generative design, and so forth have the power to disrupt your businesses, your industries. But what about Autodesk business? We're not immune to these trends. Some of the things that Tom just talked about have profound implications for the way we deliver value as a supplier of design tools. In fact, what if I could deliver to you not a design tool, but an AI-based design partner? What characteristics would be important to you in such a partner? Well, I can tell you for my money, I want a partner who is going to bring a wealth of experience to the project right from the beginning. And I want a partner who has a real curiosity and a willingness to explore and to push the boundaries and challenge assumptions. A partner who will stay up late at night and do more than I ask of them, to go beyond, above and beyond what's needed to get the job done. And perhaps most importantly, I'd want a partner that gets better over time, that learns from experience, so that together, as we move from project to project, we improve. In fact, what if we could build the Siri, the Amazon Echo, the Google Home of design and make? What might that look like? Well, Autodesk, open Project Toronto.
Loading project. Last night, the surveyor updated the laser scans. I have converted the scans to a 3D model.
Fantastic. So bring up the second floor, give me the 2D floor plan, and let's start the space planning application.
Okay, here is the floor plan. Space planning tool initialized.
All right, and let's go ahead and add the outside view module.
Okay.
All right, now let's import the program and user preference spreadsheets.
Okay. Program and survey imported.
Fantastic. Now let's launch the study, the space study, and give me about 1,000 design options.
Okay. Starting the adjacency preference, work style preference, buzz, productivity, and view analysis. Estimated time, 6 seconds. Studies completed. Running the daylight analysis. Estimated time, 3 hours. Would you like to see a predictive model that is 98% accurate? Estimated time of predictive model, 7 seconds.
Well, I don't think the audience has the patience for a 3-hour analysis, so let's go with the predictive model.
Okay. Running the daylight predictive analysis. All studies completed.
All right, show me all the results in one design exploration graph.
Okay. Here is a parallel coordinate plot representing 10,000 designs within the criteria range.
Okay, 10,000, I'm not getting much out of that. Give me 3 plots that compare the various design criteria.
Displaying plot diagrams.
Okay, well that's a little more useful. How about giving me the top 10 best designs as rated by productivity, work style preference, and sunlight?
Okay, here are your requested design options.
Okay, that's good. I like number 5. Let's go with that one. Go ahead and send the proposal to the client and send a copy to the contractor.
Okay, a VR and 3D model as well as 2D documentation have been sent.
All right, who wants one of these? Yeah. All right, so admittedly, the vision here may be a few years away, but maybe not as far away as you think. Because if anything, we hope you walk away today realizing the future of making things is a whole lot closer than anybody expects. Now, what can you expect of Autodesk? What are we going to do to help bring this future into our present-day reality? Well, first of all, you can expect us to continue to innovate. You can expect us to do it in an open platform. And hopefully, you can expect us to continue to be a force for good in the industry and in the world. When we talk about innovation, well, you saw some insights into where we're investing our innovation today. And to tell you the truth, we just touched on the surface. If you came to San Francisco, if you went to Pier 9 in our research labs, you'd find people working on robotics and machine intelligence and advanced manufacturing, but you'd also find nanoscale design and life sciences and synthetic biology, really fascinating things. But what about openness? I mean, we've got to bring all these things together into a platform of reality, and we do that today with our next generation of cloud-based products, products such as Forge, our Fusion 360, BIM 360, and Shotgun, the products that serve our manufacturing, AEC, and media and entertainment markets respectively. But we can't do everything. As broad and diverse a company as Autodesk is, there's still a whole lot more smarter people outside the building than inside the building at Autodesk. So how do we tap in and leverage that? Well, this is why we brought forward our new platform that we call Forge. And Forge is really, think of it as a set of microservices and infrastructure that we're building all of our cloud-based products on. But most importantly, in this context, we have opened that platform up to third-party software developers, to customers, and even to competitors. Anyone can develop on Forge. Anyone can add value to these platforms. Think about that unique piece of IP, something that makes your company differentiated. How would you like to be able to use Forge routines to integrate that directly into the commercial off-the-shelf software from Autodesk so you get the best of both worlds? The economics of commercial off-the-shelf, the differentiation of your intellectual property. So we've talked about a lot of things today. We've talked about technology disruptions, the need for sustainability. The future is incredibly bright. We want to be a part of that. We want to be there with you. I hope you enjoy the rest of the day. Thank you very much for your time, and welcome to the future of making things.
Wow, mind blown. The future is definitely not coming. It's here. And with the advent of quantum computing that is billions of times faster, millions of times less hungry for energy, and thousands of times smaller, we're starting to process things that much quicker. And the internet has been through many upgrades. And today, the internet is at something called Internet Protocol 6. And Internet Protocol 6 has the ability to connect 78 octillion devices. That's 78 billion things can have their own IP addresses. So the Internet of Things is very much right here. And we're about to interact with it with these amazing tools that you've described to us. Thank you so much. I really enjoyed those presentations. Next up, we have somebody all the way from San Francisco. She is a senior product manager in emerging technologies. Her name is Tatiana Jambazova, all the way from San Francisco. And she's going to be introducing us to brand new worlds. Her talk is called Recreating Reality. Tatiana, please join me on stage. Welcome. Thank you.
Good morning. Do you guys need to stretch a little bit? Are you okay? Okay, so I would like to bring you to a slightly different world. And we will start, I'll start with a story. This is the common raven. Apparently, it's the most intelligent bird on the planet. Sadly, lately, this common raven is having a lot of fun in the California desert. He's attacking the baby tortoises. And this is what we see almost daily for the last 10 years. It's just fascinating, and we don't quite understand why it's happening. So what's going on is that the raven is attacking the babies, and we are so bad in this story that we're down to the last generation of tortoises. If we don't find a way to solve this problem, they're gone for good. Why is this happening? Well, we're building cities. Cities produce garbage. Garbage produces a lot of opportunity for scavengers. So we've messed up the world. So we need to fix it. And there are two humans who said, we'll fix this using technology. I would like to introduce you to Dr. Bill Borman and Tim Shields. Dr. Borman is a scientist who has spent all his life in the California desert with these tortoises. And Tim Shields is somebody who is a big entrepreneur and knows that technology offers new opportunity to solve old problems. So they said, let's make a techno-tortoise. And the techno-tortoise would be a fake tortoise that they want to put in the desert to lure the ravens, to observe how they do it, and then to rewire their behavior so they don't do it anymore. So how did they do that? First, they digitized a tortoise shell. Using photogrammetry, a simple process of just taking photos around an object, they were able to create a 3D digital model of a tortoise. Very convincing one. Then, using 3D printing, they were able to make lots of different types of the tortoise until they arrived to the shape and the color that they really needed. And the idea was to put these tortoises in the desert. So the first thing was, can we lure them? Will the raven be fooled? He definitely was. For 10 minutes, this stupid raven was trying to find a body in this fake tortoise shell. So hooray, we did that. And obviously, because we knew where we put the shells, we put cameras, webcams, so we could record the behavior and really understand what's going on. But how on earth are we going to rewire the behavior so they don't kill them anymore? Well, that's the interesting thing. The scientists are now testing pressure sensors that they want to put on each of the tortoises. And every time that the raven attacks the tortoise, it would spray a little pepper spray. And the raven would definitely not like it. It's nothing dangerous for the raven, but he definitely doesn't like it. And after 3 times, if it is really the most intelligent bird on the planet, he will say, "I'm out of here, man. This is not for me." This is one of those stories that made me move from architecture to technology. I really love being in a team that enables small players to play big games, because tortoise scientists don't have money. And these guys managed to do this with very little budget. They used photogrammetry, which is basically free photography. They used 3D printing, which is a democratized way of making physical artifacts. They used Arduino to make them move. They used Kickstarter campaign to fund the project. And they even now look to create a game using IoT sensors where couch potatoes will finally become citizen scientists and will help control, follow the tortoises and impact the ravens or scare them off from the digital world. It's a really brave new technology world we live in. And come on, guys, we were just spending the last hour talking about reality capture sensors, drones, robotic systems, additive manufacturing, artificial intelligence, and we sit here and pretend everything is normal. Well, it's not normal, because this is the fastest period of technology development that has ever happened. And new technologies enable us really to find new ways to solve old problems, but also create lots of opportunities. And I have some news for you. It is not anymore just architects and engineers and designers who look at technology to solve problems. I've been lucky in the last couple of years to work with some amazing people who have dared take these technologies to solve very different problems. And I would like to talk about them today. So where does this all start? Sensors. So we live in an analog world, but everything that we do today happens in the digital world. So how do we transfer this analog world into the computer? The first way to do that was laser scanners. They're just shooting laser beams in space, they hit the first surface, get XYZ coordinates, bring it back into the computer. And what happens in the computer after being processed with our software, it looks like this. This is amazing. None of this has been modeled, and it looks like real world. So great. This means that we can not anymore start projects from zero in a blank screen, as we usually do, but start in context. And then there are a myriad of completely new sensor devices that appeared in the last couple of years. We're talking about structured light scanners, white light, blue light, Tango, Kinect. All of these devices have the same thing. They're sensing the environment, and they can bring it into the computer. What I'm mostly excited about is the process of photogrammetry. This is basically just taking a series of normal photos with your phone or with any camera, and then you load them in the software, and with the power of the cloud and some smart algorithms, automatically you're getting a 3D digital model that is unbelievably beautiful. Now, could you have modeled this with 3ds Max or Maya? Of course you could have, but you need to be an expert. It will take you at least 3-4 weeks, and it will never be a replica of the real object. It will be an interpretation. This one is a real replica of the real object. And if all of that was not enough, we live in an age of drones, where earlier, if you needed to do a survey of a land or capture a building, etc., you would need to hire a copter, and it was usually $25,000, $40,000. Now, for $1,500, you can buy a drone with a super high-resolution camera and fly as often as you want. So this is just a small capture of this. And you can see, if you have ever tried to fly a drone, if you've not tried, don't be scared. It's so easy. It literally can follow you. You walk, and it follows you like a dog without a leash. And you can basically use drones to capture any context in which you work, or capture a site, so it can help you with planning of the site. And with our smart tools, not only we can create a high-resolution mesh from this photogrammetric process, but with the other tools, we can create, in this case, a fully isoline model, and then get the volume and the surface of the site that you need to excavate, etc. So when we started to look at this trend and started to develop the products, of course, we were thinking only of architects and engineers and civil people, etc. Because all of them needed context to work in, and all of them needed to follow progress of the work, progress on construction site, etc. But the opportunities of these technologies are much bigger. we don't only use these technologies today to create new things, but to save our heritage. Because let's face it, we're losing our heritage on a daily basis, be it because of earthquakes or tsunamis, of wars, of acidic rains, or terrorist attacks. So what if we can start digitizing the history? Because what kind of future can we have if we keep on losing our history? How will we learn from what we have done? So maybe we don't have time or money today to reconstruct all of these things or restore them, but at least when we digitize them, we can experience them as if we were there. They will serve as digital blueprints for the future, and we would have done a good thing for the future generations by creating an archive of our heritage. This is the city of Volterra. We went there because the city realized that they have so much beautiful architecture, not always budget to preserve it, and capturing it and creating beautiful, beautiful 3D representations in which you can do virtual tourism, you can do fly-throughs, and explore if you have never had a chance to go there. In Asia, the government of Rajasthan is one of the first who really saw the opportunity. They have unbelievably beautiful palaces, and not only they're digitizing these palaces for the same reasons, for archival purposes and for restoration, but they also march towards smart BIM and smart cities, and they will be using IoT sensors to also follow the development and the impact of the environment on these buildings, but also use them as a part of the city to plan around them, etc. But believe it or not, the first people we worked with on these technologies actually came from Africa. And it is the Leakey family, in particular, Dr. Louis Leakey. For those of you who don't know, the Leakeys are very famous fossil hunters. They've been operating for the last 3 generations and 6 decades in Kenya and Tanzania. And they have uncovered the oldest ever found fossils of the first humans, of the first animals, of the first tools. Sadly, everything that they have discovered in the last 6 decades is in the Museum of Nairobi, where the collection is fantastic, but how many of us do go there? How many scientists who need to have access to this can go there? So this was something that was bothering the Leakeys. And they said, all we do is about sharing the knowledge. But aside from a couple of National Geographic articles and papers, the knowledge is kind of stuck. So Dr. Louise Leakey came at TED, where we had one of our photo booths there. And she came and she said, what is this thing? And we told her, oh, you sit down and it takes a 3D digital model of you. And she said, oh my God, I know a much better use of your technology. So she was super curious. We taught her how to do photos. And super modest, she started digitizing one by one of all the fossils. With her team today, they're digitizing daily the collection. And as you can see, these models are quite fascinating, thinking that they're done just from photos. So instead of having a boring website on which you have a photo, you have a text, and you go, you read, after a couple of minutes, you're kind of bored, and you let go. Today, she is displaying all of this on an interactive site called africanfossils.org, where be it you're an aficionado for archaeology, be it you're a teacher who teaches about our ancestry, or a scientist, you can go, you can explore the 3D models digitally, you can search by age, you can search, is it a hominid, is it an animal, is it a tool, and really offer this material in a brand new way. And just to show you, this is a photo and this is a capture of the 3D model. It's quite fascinating. We're also developing tools where she can actually explore interactively in browser skulls concurrently. So often you need to know which one is bigger, how the form morphed and changed, and she can do this with our tools as well. And this is actually happening as we speak. It's a fossil elephant skull that is 4 million years old, and it is extinct, but it's actually ancestral to today's elephants. This is not yet published in paper. You're actually the first people to see this. What is she doing other with these things? When you go on the site, you can actually download the 3D models. You can download them from 3D printing, or you can download cardboard patterns to laser cut and build together. Why is this important? Well, imagine you're at school. Instead of asking the kids, hey, open book, page 50, and tell me, what's the difference between the Neanderthal and the other guy? Well, instead of kids learning on the other by heart, they can literally print them or use these cardboard replicas and compare them and see, oh, the skull of this guy was more round, so he had more brain, so it means that he must have been smarter. It's an experiential learning in which science can actually be fun. The other story is with Sly Lee. Sly Lee is a marine biologist who is researching corals. And you know, corals are unbelievably important. They save us from hurricanes. They host biodiversity that is richer than the rainforest. But sadly, he realized there is no scientific way to measure if the corals are shrinking or growing, if they're healthy or not. So he learned about our technology and said, why don't I do this underwater? So he set up shop, this is his shop, and he started diving. He's doing absolutely the same thing. He's taking a bunch of photos from, in this case, from the coral reefs, with the idea not only to do a digital replica and a snapshot in time of these beautiful corals, but also to compare states of corals over time. So he captured, for example, in the Maldives before El Nino came there and after, and by capturing two states and comparing, and we actually did the comparison feature for him because we realized that that is the need, that's the value of working with disruptors, to really see what is the impact of, be it climate change in general, or in this case, of a hurricane. And obviously, because the models are 3D, they're beautiful, they can be explored digitally, but also they can be 3D printed and touched, something that you would not do. So many of us, like me, who are scared to go deep and dive and see this, have an opportunity to explore this either digitally, online, or download the model, print them. This started to become so popular, given our recent stories about the coral reefs, etc., that Sly started to get inquiry, but a lot of divers and people who care about the ocean and say, how can I be part of this? How can I do this? Because the idea is, can we create a digital platform where all the divers in the world can, whenever they dive, capture some corals, upload the photos. There is a curator who uses those photos. We create 3D models, and we are doing a time machine, because if I dive today and you dive tomorrow, etc., and we all upload the photos, then we just go through time and see what has changed. And that is where we think that this is going. But given the interest, they started to make expeditions. So you can sign up. You will be taught how to take pictures and how to have an impact on raising awareness about what's happening. And I don't want to completely depress you, but these are some pictures that the latest expeditions, first Sly did them in December 2015 of a healthy coral reef, and this was the same reef in 2016, completely bleached. And in December 2016, this was a dead coral. Just imagine living next to a big stinky mud instead of an ocean. What is he using this for? Well, first, obviously raising awareness about global warming, about climate change, but also more practically working with local authorities to at least impact the stuff like cyanide fishing, overfishing, etc., so that the local authorities can talk to the fishermen and explain that if they do overfishing, if they do cyanide, they're killing the corals, and they will soon not have anything to live from because there won't be any fish either. You can check this, the corals on this site as well. By the way, I just connected them with this startup, which is OpenROV, who are making drones for underwater that are do-it-yourself, so we can see if we can serialize and make this process a little bit faster. This is another startup, yet another disruptor. They're called Digital Life 3D, and they've developed special scanners with the idea to make a life library of all the animals that are alive today. So it's not preserved animals or killed animals. These are animals who are usually on the brink of extinction, and they've developed these special setups, beast cams, where they have multiple cameras shooting at the same time, because you know animals can move, and that doesn't work for photogrammetry. But they started capturing lizards, extinct tortoises, sea turtles, and also some other species. It's quite fascinating how easy it is today to have a good idea, a big heart, and to be fearless to go into this. In the latest issue of National Geographic, this story was covered about the Panamanian golden frog, and This is just one of these captures to show you how real this is. And just imagine when CAT scanning and MRI scanning that is for inside, not just for outside, gets just as democratized as it is the line of sight, and we're able to literally create 3D digital replicas of every living piece. Now to something else. A couple of years ago, the Swedish Museum in Sweden was preparing a new Egyptian collection exhibition, and they invited us as technology partner to see how can we use technology to make a better in-museum experience. So they gave us the body of the priest Nesvayu, an Egyptian priest, and they said, do something. So we took the body and stuck it in an MRI scanner. And then the rest, we took photogrammetry of the sarcophagi, of the both of the sarcophagi as well as of the cartonnage. So we ended up with a 3D digital model of the mummified body, of the cartonnage, of the first sarcophagi, the second sarcophagi, basically of the entire mummified body. To do what? So Interspectral, who is specializing on this interactive tablet, put this digitized mummy on this tablet that is now in the museum, just before the glass behind which the dusty mummy sits. You cannot see it enough, you cannot touch it. Here, this is the end of no touch. You can now touch, slice, unwrap, undress, poke inside the mummy, do whatever you want. And you can zoom in up to the latest pearl, up to the latest hieroglyph here. And because the models were 3D digitized, we could also 3D print them and assemble them like Russian babushka dolls. But this is interesting. We found about 120 hidden amulets under the wrappings of the mummy when we did a CAT scan. And guess what? We could 3D print them afterward without unwrapping the mummy. Actually, we did the lost wax casting process where we 3D printed the amulets, and then you do plaster, you burn it, the same thing, pour bronze, and then you make a bronze cast. So actually, the 3D print serves as the lost wax casting in the casting process. I was at the opening of the exhibition, and it was fascinating. Instead of seeing the kids dragging the parents, I want to go home, this is boring, it was the opposite. The kids would not leave. And I'll never forget this girl, when she came and she looked, and I wanted to show her, and she said, stop, don't show me, I know. Because, you know, they grow up with iPads. This is the way these kids learn today. And she will never forget what she did there, and it was quite fascinating to observe. One of the bigger stories that we had lately was with the Smithsonian. The Smithsonian is the biggest collection of museums in the world. They have about 19 museums, 2 research centers, 1 zoo, and they're spread across 100 countries. And they have 154 million objects. Now, if you're somebody like me who goes to museums, you might be disappointed because this is all you see in the museums. You see just 1%. Why? Well, they don't have enough space. There are not enough buildings to expose 154 million objects. So they unfortunately sit in archives under the buildings or outside in separate storage rooms, facilities in DC. So the Smithsonian wanted to solve this problem of access of the entire collection, but they also wanted to solve the problem of how to engage the young kids of today who think that museums are boring, archaic institutions, that there is nothing interesting for them there, and who want to consume content digitally. So they realized that these reality capture technologies will enable them to offer this content worldwide to anybody. And they started digitizing. They used micro-CT scanners, Surfacer, Faro, ARMS, photogrammetry. They really knew nothing when they started. They were learning by doing. They were fearless. And they managed to do it. They learned how to make really beautiful 3D digital replicas. And then they came to us, they said, you Autodesk have all of these beautiful tools, Maya, Max, can you help us present this content in a beautiful way to the world? Well, we soon realized they didn't need just videos. They needed an online tool that will let any one of you at any time, without any download, without any installation, without any knowledge, to explore the whole collection and see what the curators can teach you about it. And that's what we did together. So this was a prototype for a museum in the future, where we picked about 20 objects that were very different, from as small as a bee to as big as a supernova remnant, with the idea to see how can we bring this in this shared online environment. It's called the Smithsonian Explorer, and it looks like this. The objects first are as beautiful as in real life and not as in Second Life, but they can be augmented. This relief was so shallow the curator couldn't read it. Now, because it's digitized, I could just deepen the relief, and all of a sudden, wow, there is more to learn about it than the actual statue that stands in front of you. So now that this was digitized, the curators, we gave them a language of the 21st century. We gave them tools to add multimedia, audio, video, to embed all the knowledge that they have spent their entire lives with developing around the objects. So imagine you're a teacher, you teach about the mammoths, you tell the kids, hey, open the Smithsonian mammoth, tell me, how tall is the leg? But we don't have to be always so serious. We can also use the same tools to create art. Let's make a sticker for our t-shirt or something like that. So you see, these technologies also enable us to make education fun. This is very interactive, and the curators are enabled to speak the language which the kids of today would be interested to learn in. And obviously, because everything is 3D printed, is 3D modeled, it can be brought into physical world with 3D printing and other techniques so that the scientists can explore those artifacts physically, or again at school, or any father at home, mother at home can play with the kids and learn about the past. President Obama was the first president in the world who did not have to wear a plaster mask in order to have his bust made. We helped digitize him, and today his statue is in the National Gallery, Portrait Gallery in DC, and it's 3D printed. And he was very cool about it. One of the latest projects with the Smithsonian was the digitization of the famous Apollo 11. And Apollo 11 is usually kept in a plexiglass, quite tight, and even the curators, out of respect, have never stepped inside. But it was going to go to another exhibition, so we said, this is the time to capture it. And because we know it won't be open again in the next 100 years, we said, we will digitize the heck out of it. So we took photogrammetry and laser scanning and structured light scanners. Literally, we tried to digitize every corner of it. And we ended up with a beautiful 3D digital model that now anybody of you can explore online. And not only explore in browser, but you can download the VR experience, and you can put Google Cardboards or any goggles or AR, VR sets, and you can sit inside the Apollo just like the astronauts were sitting. Actually, Michael Collins, who was the third astronaut who stayed in the Apollo while the other two were dancing around the planet, he actually came to the Smithsonian. That is him here. And we showed him how kids of today can explore and understand his experience. And again, because it was 3D modeled, we could also make a 3D replica. The Smithsonian allows you also to download all the models and use them in education, use them for fun. This is now something completely different. These are the Bamiyan Buddhas. They are one of the most glorious statues in the world. They were carved on a cliff over 1,000 years ago. Absolutely beautiful, strong touristic site. Many people were going there. Sadly, in 2001, Taliban dynamited them from religious reasons. The world was very sad because this was what remained. From the colossal Buddhas, we just had left over a hole in the wall. So some smart colleagues of mine said, what if? What if we try to find the personal memories of all the tourists who have through decades been going there and taking pictures, and find those pictures on Flickr, on Google, download them, and try to reconstruct the Buddha from those photos that were taken. This is now a 3D digital model created by all of us who have been there, made some personal memories, and all together we created a collective memory and managed to reconstruct something that doesn't exist anymore. Now, was this perfect? No, because half of the photos were analog, etc. But imagine with the sensors that we have today, with the cameras that we have today, how easy it is to get involved and to help save our cultural heritage, save our natural heritage. I started with turtles, and I will finish with a turtle. Only this time, this is a South African turtle. This is the diamond turtle. It's a geometric turtle. It's one of the rarest turtles in the world, and sadly, it's on brink of extinction. The reasons, again, crows and ravens. also some other wildlife, but also climate change. Thanks to the global warming, there is a lot of drought and there are lots of fires that are killing the bushes where these turtles are living. So this is another disruptor, Professor Margareta Hofmeier, who with the help of Professor Jim Juig, decided to analyze the life of these tortoises and do something about it. And as we live in a digital connected world, they heard about the tortoise project that we did in California, and they contacted us. And they said, can we do the same? So I'm holding in my hand the 3D printed turtle that you can see there that she has not yet seen because I just brought 50 of them to South Africa. And they will try to do the same thing, but this is the same story. Made out of photos, 3D printed, and then it will be put in the desert and observe the behavior. Maybe in South Africa they will try with pepper and salami. There is nothing is stupid as long as people who care try to do it. So as you can see, the people behind these stories have been using the democratized sensors, photogrammetry, photos, laser scans, the democratized ways of production, which is 3D printing, other CNC machines like laser cutting, etc., and the brave new world of WebGL and 3D web and augmented reality, virtual reality, to convert what's real to become digital and then to become real again. We call this concept rip, fix, burn. You rip the reality, just like we ripped music, and then you mix it, fix it, and you burn a new CD with your, right? In this case, you 3D print. Or rip, mix, learn, where we can rip the reality, mix it, and learn from it. These are the people behind the stories. They have dared, they have tried. Many people told them they're stupid, that it will never work, but they managed to do it. So the question for me, for you today is, what will you disrupt? Thank you.
I'm getting tired of saying this. Mind blown. Wow. 3D printing for me is really exciting because soon enough it's going to be impacting our bodies. I don't know if you saw that last year they had the first Cyber Olympics, where human beings are now able to put robotics onto our bodies and then compete in competitions. I myself want to know, can I get taller? Can anybody tell me, can I raise maybe 6'5"? No? Not that yet. Okay. Well, guys, we've come to a break. We got the track session starting at 10:20. So you have about 18 minutes to grab a coffee, go to the loo, and then you've got over 30 track sessions to choose from. Really have an incredible day. Thank you so much for joining us for the first bit. Ciao.